research and application and so on. And in addition, has delivered many talks on machine learning and deep learning at various engineering colleges throughout the nation. So with this few words, I would like to introduce, I wanted to introduce our today's speaker, and over to you, sir.
Yeah, thank you so much, Dr. Pawan, for such a nice introduction. Right now, thank you so much, sir. So with this, now we will start our second session, which is on introduction to machine learning. I'll share my screen. Yeah, okay, sorry for the delay. So now we'll start with our second session, which is on introduction to the machine learning. I'm sharing my screen. Hopefully the screen is visible. So suppose in between, if anything happened just because of the connectivity, please let me know on my WhatsApp, because I'm only handling the session, and maybe in between some of you are joining. So I'm getting the request also to admit in the Google Meet. So there will be some disturbance maybe, but we'll try to minimize it. Okay, right. Fine. Okay. Okay, so hopefully my screen is visible.
Yes, sir.
Thank you so much, ma'am. Fine. So in this particular session, I will be talking about the introduction to the machine learning, and we'll try to understand where exactly the machine learning is in the area, is in the computer science and engineering branch, right? And how to which of the area it is closely related. For example, we say that artificial intelligence is one of the area of the computer science, and the machine learning is closely related to that one, right? So we'll try to understand the difference between the AI and the machine learning. So we'll start with that. Okay, then we'll understand how exactly the machine learning system works, on what basis, what is the working principle of the machine learning system, how it is different from the conventional learning. That is very important, right? In earlier days also, we were doing some of the computation through the machine. Now we are also doing the same thing, but the now scenario has changed, right? We can do a very complex things within a second also. How is that possible? How is the learning happening, which was not happening previously? right? Around 20 or 30 years back. Right, so those things we'll see in the introduction part of the machine learning. Then we will see the different applications of the machine learning, which we are using in our day-to-day life. So I'll give you some of the examples of that one, that what are the things, what are the machine learning tools we are using in our everyday life, right? Then we'll see different variants of the machine learning. There we will try to like categorize the machine learning system into 3 types: supervised, unsupervised, and reinforcement learning. Okay, and then we'll see different or various popular algorithms of the machine learning. I'll just give you names of a few popular algorithms, which maybe we will learn some of them in our coming sessions. Then we'll see the Python for the machine learning. And finally, Python for the machine learning, why I have included, because we are having the hands-on sessions, right? And I'll tell you in the Python for the machine learning, what are the different tools or what are the different library we should be aware. Right. So if you're not aware, that is also fine. I'll give you a detailed explanation that which library we have to use, how we will import that one, from where, and all, everything I'll tell you in the hands-on session, because that is taken by myself itself. So I'm pretty confident that I can explain you those things very well. So don't worry if you are not aware of that one, but if you are aware, then I'll tell you to go through those some of the library which we will be using to building our networks, like, so that you will have the fresh revise on those the libraries and all, right? And finally, we'll conclude this session. So now, to start with the introduction, the machine learning is a branch of artificial intelligence. So as I said before, that where exactly the machine learning fits in the computer science. So the first line here, it clears that the machine learning, it is a branch of artificial intelligence. So we have artificial intelligence as a superset, and then machine learning is just a part of that one. Fine. The second point says that machine learning system learns from the previous experience. Now, this point is very important. I'll get back to this point. But before that one, let me just differentiate the machine learning with the artificial intelligence. That, and then to which machine will say that it is a machine learning system, and which machine we will say that it is an artificial intelligent system. Let's differentiate that first of all. First, I'll just try to recall what our director had said, that a machine, artificial intelligence system, the definition nowadays, it is that if a system is capable of mimicking what the humans can do, okay, that if a system can manage those things, what the humans can do, then it is an intelligent system. For example, like what he said, that with the data storage, okay, the management of the data. No, that is not, if a system is doing the management of the data, that system will not called as an artificial intelligence system. Why? Because the humans are not capable of that one. So if you have suppose huge data, right? So it will be very difficult for the human to manage that one. So, but system can do that efficiently. But those system will not called as the artificial intelligence system. Fine. That is one of the example what he discriminated, that which system will we say that as a artificial intelligence system, or which system we cannot say. I'll give you another example to understand this two terms, machine learning and artificial intelligence. Suppose we have one automated car. Okay, nowadays people are working on the boat. Okay, a boat could be anything, right? For example, automatic self-driving car, right? So just understand how exactly the like a self-driving car works. For example, suppose we are just seeing the trial of the self-driving car, a boat. But if we see how exactly that car works, means if it is running on the road, right, and suddenly some object comes in front of the car. So what that car supposed to do? It should press the brake so that it can slow down its speed. It should not happen that it is going to dash that particular object. Okay, that object could be anything. That object could be a human, it could be another vehicle, or it could be anything, right? So the boat or that self-driving car should be sufficient, it should be self-intelligent, such that it can understand the scenario, it can understand the environment, and based on that one, it can make the decision. right? If the car is capable of doing all these things, then that car is known as the artificial intelligence system, because it is its intelligence who can decide that at which situation, which process it has to perform, isn't it? That is called artificial intelligence system, right? Now, in the artificial intelligence system, the same example, that self-driving car, if you look at carefully, it is made up of number of machine learning system. It is featured with the number of machine learning system. For example, suppose it has to see which object is in front of that car. So for that one, it really needs some image processing sort of thing, that it will capture the image or maybe the video, and then it will do some processing on that one. It will try to establish how far that object is from the self-driving car, and then it will make the decision. So taking the picture, say, or taking the video, processing that video, now it is a part of the machine learning system. You can say that, right? And then there are many other functionality that the car has to perform. And most of them could be the machine learning system. So we can say that to build an artificial intelligence system, we need to integrate many machine learning system together, right? So a machine learning system alone is not an artificial intelligence system. But if we are going to integrate many ML systems together with some other functionality, then it may happen that we build one artificial intelligence system. And that's why the first point, it is clearly says that ML is a branch of artificial intelligence. ML is not an artificial intelligence, but it is a branch of artificial intelligence. Other way, I can also say that machine learning is a way to achieve the artificial intelligence. Okay, so we can start with the ML learning, like building one ML system, and then we can integrate more features into that one, such that the system will self-capable of deciding what it has to do, what it has to not, based on the environment, right? I guess now it is clearly understood that how machine learning system is different for the artificial intelligence system, right? Now the second point, as I said, that how machine learning system learns. So it is written that it learns from the previous experience. It learns from the previous experience. Now, what is previous experience? What do we mean by the previous experience? So previous experience means that what we have seen in the past. For example, that suppose for a child, okay, 1 year baby, for a child, we are showing one object to him or her, right? For example, we are showing the mobile to him, and we are saying that this is a mobile. Okay, for the first time, like when we say that one with the annotation, by showing the object with the annotation that this is a mobile, the child can understand, can remember that, or it may happen that he or she will not remember that whether what is that object. Second day, suppose we are showing the same object with the same annotation, that we can ask the child that what is this? We do ask, right, to the child that what is that? If he or she will not answer, we say that this is a mobile. Fine. Now suppose same thing happens for the 10 days, continuous 10 days. And 11th days, what happens? Surprisingly, if we ask what is this object, this child will reply you that this is a mobile. Now see what happens basically. How exactly now the child is replying whether that particular object is a mobile or not. Okay, so what is happening from the last 10 days? It was he or she was seeing that particular object, so that he gained some experience. He got some experience that this is the shape, right? It has some glass screen in the front, right? It has some camera maybe at the back. So he or she has observed something. And if 10 times, if we are showing the same object to the child, the 11th time, if we will ask the child that what is that object, he may reply you correctly that it is a mobile. And that is called the previous experience. So from the previous experience, whatever it has seen from the last 10 days, now he or she is able to give the prediction that that particular object is a mobile. Now, it may happen that whatever he is saying, right, he or she is saying about that particular product, that may be wrong. The prediction cannot be true all the time, right? For example, suppose I'm showing a ball, a tennis ball to the child, and I'm asking that what is this? Suppose in the training time, he doesn't know what is that object. So we will annotate that one. This is a tennis ball. Second day also we will show the same object, tennis ball, and we'll say this is a tennis ball. 10 times suppose we are showing the same object, tennis ball, and we are saying that this is a tennis ball. Obviously, like it is a high probability the child will learn that one, that if it has the round circular shape, right, small maybe in size, whatever we know what is the size of the tennis ball, then it could be the tennis ball. So on the 11th time if you will show the same object, the circular thing, and so the child will reply you this is a tennis ball. There is a high probability yet, right? But suppose on 11th day, instead of showing the tennis ball, you will show the football or the volleyball. Instead of showing the tennis ball, you will show the football or the volleyball to the child, and you will ask, what is this object? Okay, so what you expect, what that child should reply? The child will reply that this is a tennis ball. Like there is a high chance for that one. Why? Because from last 10 days, he or she is seeing that if an object which is a circular, right, then every time it is being annotated by the tennis ball. So I must answer that this is a tennis ball from the previous experience. But his answer or her answer is wrong. This is not a tennis ball. This is a football. This is a volleyball. We can say that one. So my point is, from the previous experience, okay, the system is predicting something, or we as a human predict something, that what could happen or what is the prediction of that particular new data or that particular new query or question. But our answer could be wrong. It may happen that whatever we have learned, that was not sufficient to give the correct answer. Right? So that's what happened. The same thing happens with the machine learning system also. So what happened? We supply hundreds of data, 10 data, 20 data, 100 data, 1,000 data sometimes, millions of data sometimes, right? And we ask the system to learn from the data. Okay, we ask the system to learn from the data. So learning means gaining the experience. So we ask the system to gain the experience today from the data, understand the data, right? And then finally, in the testing time, we ask the question, or we give the new data and we ask the system to tell me the answer of that particular data. Are you getting? So now we can clearly understand that one. This machine learning process works in two different phases. First one is learning, and second one is predicting or the testing. Right? For example, one more example I'll give you, that we will go through this 5 days FDP courses. So from first to fourth day, and even in the fifth day, first two session, we like different speakers through the hands-on, through the theoretical sessions, will try to teach you some of the aspect of the machine learning system. And then I said that at the last session of the FDP, you will have the assessment, right? So in the assessment, you will be asked some questions and you have to answer that one. Now see, the 5 days, still 5 days, second session, there is a learning phase for you. There is a learning phase for all of us. But in the last session, there will be a testing phase. So again, see, everything it's just like whatever we are doing in our day-to-day life, similarly, the machine learning system also works. So we are also in the two different phases. So we will first learn, and then we are going to give the assessment. So that is the testing phase. Similarly, machine learning system also, in the first phase, it learns from the data, gain the experience, understand the data, and finally, in the testing time, when it will be asked some question, it has to predict. And then what we are expecting, that machine should predict accurately. Accurately means in the scale of 0 to 100%. Now that accuracy could be anything. It could be 10%, 20%, 50%, 90%, and 100% also. The same thing I can expect from you also, that whatever you will learn in these 4 days, 5 days, while giving the assessment, you should get the 100% marks. Suppose there are 10 questions, you should get 10 out of 10, 9 out of 10, 8 out of 10. If you are getting less than 16, 6 out of 10, then there is a problem for you. The same thing we are also expecting from the machine. So I'm just trying to compare that whatever we do in our day-to-day life, in a similar fashion, machine learning system also works. Okay, right. So now we understood what is the learning, how exactly learning happens with the machine learning. Okay, just a second, I'll put on charging. Yeah. Okay, fine. Sorry for the inconvenience. Right. So now, as we understood the learning process of the machine learning, now let's understand, or let's try to relate some of the machine learning algorithm, what we are using in our day-to-day life. I have listed a few examples. The first one is virtual personal assistants. Now, what is virtual personal assistant? For example, I have given a few names like Alexa, Siri, Google Now. Now, Google Now. So most of us, right? Most of us, we are using the Android phone. An Android phone has this features which is coming with us, that we have one Google Now like option. So as soon you will open your mobile. So if you have not, so you will get that Google Now option on your screen. And that Google Now, basically it is a virtual personal assistant. So if you will if you will say, okay, Google, okay, and sometimes you have to press the microphone. And if you'll say, okay, Google, open the contacts. So what the Google Now will do, it will open the contacts, your contacts in your mobile phone. If you'll ask the, okay, Google, open the music and play that particular music. So it will try to find that particular music in your music library and will try to play that one. So you can give the instruction in the form of speech, and what happens that Google searches that one for you, right? And then it finds that for you, and then it plays that for you. How it is happening? Why? Because, so see, there are millions of people, everyone, the way we are giving the instruction, right? And the way you will give the instruction, the language in which I can give the instruction, the language in which maybe someone else will give the instruction. Now it is all together, it is different. Although it is a one language also, English, say, suppose Google Now is trained for the English. So if the way I will give the instruction, the way in which my style of speaking and your style of speaking, it is completely different. But still, Google Now manage that one, and for all the instruction, it will give you some of the output. Or sometimes what happens, whatever will give the instruction, it will give some random output, some output which is not correct, but it is giving some prediction. So now you can relate that this Google Now is nothing but a machine learning system, basically. So it has been trained. It has been trained for these instructions. So suppose if someone will give you the instruction in this way, that open the contact, then how you will give the prediction. So Google Now is trained for that one. Similarly, Alexa and Siri, these are all the virtual personal assistants, and they are trained. So you can talk with them. Okay, you can talk with them. You can ask them what are the schedule for the tomorrow, today, and they will answer you. So it's like that you're talking with your colleague, you're talking with your peer, right? So these are nothing but machine learning systems. The second example which I have listed here is predictions while commuting. So you are in your vehicle going from one place to another place in your city, and you know that there is a high traffic in the evening. There is a high traffic, there could be, there is not always, but there could be high traffic in the evening in this particular route when you are going to the airport or to the railway station, suppose, right? And you want to know that which route, because you don't have much time, you have to reach the airport, you are already running out of time. So what you will do, you will take the help of some of the machine learning systems, say the traffic prediction. So you can ask, so you might have observed in the Google map, there is a feature that they can tell you that there is a heavy traffic in this route, you can take some alternative. You can take the diversion from this point. How the machine is able to figure it out? Right, machine is able to figure it out because it has seen from last 1 year, maybe some data, last 1 year, 2 years, and in the everyday data, the time basis also, that in the morning 5 o'clock, in the evening 5 o'clock, in the afternoon 12 o'clock, what is the traffic in this route? It has all the data with it, right? And then based on that one, it is predicting that there is a heavy traffic in this route, you can take the diversion. And then you are being a smart, so because system has told you, you take the traffic. But what happens that because system is learned based on the data, based on the previous experience, it is predicting something and we are following, right? But there might happen that suppose due to some thing on Monday, there is a heavy traffic in a particular route, right? But due to some reason, suppose there is a band or something, nowadays system is again capable of saying that this road is closed. Okay, for a particular day only, it will say this road is closed. But see how the system is intelligent. So the way of the whatever, so maybe in the first person or second person it will go, it will not able to tell that one. But the system, if it will observe that there is no the vehicle is going from in this route, although it was going in every day, there was a heavy traffic at this point, then system can label that one, or the Google Map can label that one, it is closed maybe. Or after 5 o'clock, there is no activity in a particular mall or a particular shop, then it is closed, right? In a particular medical or in a particular hospital, there is a timing between 4 to 7 of visiting a doctor, then it will tell you clearly that 4 to 7 it is open, after that it is closed. So system is capable of learning. So it learns from the activity what we do in our day-to-day life, and based on that one it is predicting. So traffic prediction, again, we are using these things, like we come across this machine learning system many times when we are traveling in our vehicle, right? Then third point, what I have mentioned there is the video surveillances, like tracking unusual behavior, detecting crime, through the image processing, video processing. Again, it is a machine learning system. Social media service like face recognition, computer vision, and online customer support like chatbot system. All these we are using in our day-to-day life. For example, chatbot system. So if you go to any service-oriented website, most of them have now the chatbot AI system. For example, if you'll ask some preliminary or the most frequent asked question, so you don't have to interact with a particular agent. A system is there for you, which will give you some of the most frequent questions. For example, suppose nowadays Flipkart e-commerce website, they have started with this chatbot system. So you can ask some of the questions about the product quality, product features, how the other the sentiment of what are the sentiments of the other reviewers or other customers about a particular product's quality. So some of the questions for which that particular system is trained for, they will give you the answer automatically. So how it will help us? So it can reduce the human efforts. So we don't have to we don't need the human to sit, and for every customer there will be one representatives and who will be interacting with that particular customer and answering all the questions. Why that is not required? Because most of the questions which are very frequent, right, and every customer asks the same questions. For example, they're asking the timing or of a particular service, or they're asking what are the features of a particular product in a e-commerce website. Now see that features for a product is fixed. Although I will ask from a customer representative, they will also answer me the same thing. So why, if we build a machine that can answer the same thing, the job will be done for us. Feature is not going to change once if the product has been launched. Right, and then in this way we can reduce the effort and the cost which we need for the human or the customer representative. So the online customer support or the chatbot system nowadays it is very famous, and this chatbot system again it is nothing but a machine learning system which had been trained for some of the questions. Now again, if you'll ask some other questions out of the box, it will not give you any answer. It will tell you to contact the customer cares, right? Because it was not trained for that one. So that's how, as I told you, that in our day-to-day life also, we are coming across many machine learning systems using the machine learning systems, right? So these are some of the examples for that one. Now moving ahead. As I told you that once we have understood the working and where and all we are using this one, now it is very important to understand Why we were not able to do these things earlier days, means in 90s, and why we are able to do these things nowadays in 2023, 2010. What change we have made in the processing, the way we are processing now and the way we were processing earlier, how it was different. Let's try to understand that one. So you can see with this figure, we can clearly make the difference how we had the conventional approach and how we have the machine learning approach. So in the conventional approach, we were giving the input to the system as input, means data, and the program. Means suppose we have to add two numbers, or suppose in a class I have to find how many of you have got 80% marks first division, maybe, or 70% or 60%, and like that. Suppose there is one task which I have to do. How do we do from the conventional approach? Suppose I'm using some programming approach. So what I'll do, I'll write the program, then I'll ask the input that how much marks you have obtained. I will give the total marks, and then I'll ask the system to calculate the percentage for that one. So what I'll do, I'll give the input, I'll give the program, and system will give us the output, right? That is the conventional approach. Now in the machine learning approach, how we do the same task. So in the machine learning approach, now see, there is some difference. So earlier we were feeding input and program to the system, and system was giving us the output. But now we are feeding input and output to the system, and based on some algorithm, system is giving us the program. Now what does it mean? So like it looks like very useless, like, because suppose we know the output of a particular program, why do we need the machine, right? That is the one question what is coming in our mind. Yeah, the answer is yes. In ML, you have to put the effort for the first time. So while making the system to learn, there is a lot of effort what we have to put. Okay, and to making the system, machine learning system to learn, we need the input and output. And based on the algorithm, the system predicts the rule, or it extracts the rule, some rule out of the input and output data. What is the rule? The rule is, for example, input output, what I'm giving is, suppose I'm giving the marks 70 as an input, and output is the first division, right? So I'm telling the system that if the marks is coming as 70, its label is first. If the marks is coming as 50, its label is second. And if the marks is coming as 30, its label is third, suppose, right? And the system adapts that one. System try to learn that one. And it try to make the boundary that all the marks which has come 70 or more than 70, all of their label was first. So in the testing time, whenever one marks will come, suppose 89. So what label the system will give? First. Why? Because system has seen in the past that all the marks which has come 70 or more than 70, every marks was labeled with first. So I should label 89 with first. Similarly, if a marks is coming between 50 and 70, in training time, all of them were labeled with second. So any marks in testing time, if it's coming between 50 and 70, system will also label that marks as a second. Now understanding. So because we know that machine learning system works in two different phases, like training and testing. While training, we have to give input and output both. But in the conventional approach, that was not the case. So now see, at the first instant, looks like this conventional approach is easy, isn't it? We have to write the program, give the input, we'll get the output. But we need to prepare the data first of all. We should have the data such that we have the input output. Then only we can feed the data in the system, and system can make those boundaries. Now those boundaries are the program, basically, what I've written here. Yeah, at the first instant, it looks that this machine learning approach is very complex. But in the real scenario, when you have millions of data, and for every data you have to find the output, you will find that this conventional approach is very, it is a time consuming and it is very costly. Because for millions of data, you have to feed with the program to the system, and system will give you the output. But here, what you will do, out of those millions of data, for some thousands of data, you can train the system, and for all rest of the data, you can simply do the prediction. So yes, in the training time, it may take some time, it may take some effort, but while the testing time, within a constant time, it will give you the output. And that is the benefit what we are getting through the machine learning system, which we were not getting in the conventional approach. And that is why the machine learning system are nowadays very popular. Because nowadays, everything on the web, everything is all about the data. Data is in millions. So we cannot predict their output one by one. It is time consuming and it will not fulfill our requirement. But the machine learning system, once it is trained, it can work for a long time. Right? So the same thing with the example I have written here, that in the conventional approach, suppose we are feeding the total marks as input, and the program will get its output as second. But in the machine learning approach, we have to give the total marks, suppose 58. We have to also feed the labels along with that one, and the system is going to extract what could be the boundary, such that I can say what could be the boundary, that all the marks which is coming more than 60 is first, less than 60 is second, and such boundary the system makes in the machine learning approach while training. And while testing is simply predict for a total marks what is the output, for a total mark what is the output, that's all. So yeah, in the first initially we have to put a lot of effort for training the machine learning system, but later on it is very easy to use for a long time, for the next 10 years, maybe for the next 15. But here, for every new data, whenever it will come, we have to do the same processing. And altogether, this becomes very complex, time consuming, and very costly as compared to the machine learning system. Right? Okay. Now, I'll move further, that how exactly a machine learning system learns from the data. I have given you that example just for the revision purpose. I think till now you might have understood how exactly we learn from the data. So we related the machine learning system learning with the human learning. So how the child learned by seeing an object. That's in the similar way, the machine learning system also learns from the data. So it gains the experience. If it sees a particular data again and again, and then it makes its prediction while testing. So suppose in the testing time, we are giving a new data to the system. So there is a 100%, we cannot say 100%, but there is a high chance that the system will predict wrong output. For example, suppose I'm teaching you the machine learning. Right? I'm teaching you everything about the machine learning for the next 5 days, and I'll ask you something from the security. So what will be your response? Obviously, most of you will not able to answer, or if you will answer, you may not able to answer 100% correctly, or this scenario will come. But suppose I am teaching you machine learning, and if I'll ask you the question from the machine learning itself, the probability of getting the correct answer will be high. Isn't it? So the machine learning system learns from the data what you have shown this machine while learning. If a similar data, not exact data, but it's a similar data you will provide in the testing also, you will get the good output. You will get the output with the good accuracy, right? Now, the applications of the machine learning, some of the application, the day-to-day application, what we are using, we have already discussed. Some other application, let's discuss where and all it can be applicable. The first one, as I have mentioned here, is disaster management. So how the machine learning is helpful. For example, nowadays all of us are using one of the social media websites. So suppose something happened at my place or at your place. So what happens? Suddenly we post something on the Twitter, on the Facebook, right? So suppose that something happened in my house itself, the natural thing which should not happen. So what will happen? Just behind it is, suppose it is 12 o'clock in the night. We do not have access to the police or any other rescue team. So what can we do? We can take the advantage of the social media website. We can post something on the social media, and that post, if it is being monitored by someone, like some government agency, some like emergency team, they can filter those posts and then they can get back to you. And that's what's happening in the case of the disaster. Somewhere, suppose disaster has happened, man-made disaster, or it could be the natural disaster, say flood or earthquake, or the man-made disaster like coronavirus. So what happens? So we write something on the, suppose we no one knows that one for the time being, because if something happens, even the news media, everything knows about that one, or the actual scenario of that particular place only after some time. But the person who is present there, they can tweet or they can post on the Facebook within a fraction of a second after the event has happened, right? And that is very important for the rescue teams or for the government agency. If something has happened, so they can immediately, they will get the information what is the situation at their place, and they can send the rescue team, right? So the disaster management can be done through the social media, text, or the data mining, and that is only possible if the machine learning system is involved into that one. Why? Because see, in the Twitter or Facebook, millions of data comes about thousands of subjects. Someone is talking about the politics, someone is talking about some other things, someone is talking about the movie, right? Someone is talking about some sports, and suddenly one post is coming about one of the disaster. So if there is a machine learning system, then system can only filter only the post which is related to the disaster and not about the sports or the politics or about some other subjects, right? So the machine learning system involvement is very important in the social media context, and then only the management of the disaster can be it can be done through the social media, right? So that is one of the application where the ML systems are very useful and applicable. Cyberbullying detection is another, one of the hot area nowadays, you can say that one. Why? Because in the social media, we do not have any checkpoint that what you have to write, what you cannot write. You can write some good thing also, you can write some bad thing also. If have to fight with you, I can write simply some wrong thing about you on the Facebook or the Twitter, and what happens? People simply take the interest. For example, it will start trolling, isn't it? It will start trending. Right, people who doesn't know, who doesn't have any involvement with that particular conversation, they will also start taking interest. Right? No, it is good in some cases, but it is bad when people start their own personal things. Right? So what happens? Basically, it impacts on the victim. Suppose I have written something about you and it start trending. So everyone knows about that one. So what happens? So earlier, the fighting was between only you and me, or between my friend and your friend. But now, all over the world, people are taking interest. They are making fun. They are telling something. They are making group. Yeah, someone in the favor, someone in the against. But who is the victim? They are basically suffering, right? So we need a machine learning system again, that if some posts are getting trained just because of no reason, that others should not need any attention or should not get, they should not get involved onto that one. A system can tell us, because for us as a human being, it is very difficult to know that which post is cyberbullying and which post is a normal post. But the system can tell us, if it is trained for that one, that way this post is a bully post, and we can stop that post, we can block that post, and we can delete that post, so that it will not propagate to the rest of the world. It will not disseminate to the rest of the world. Again, machine learning system plays a very important role in those scenarios. Sentiment analysis, for example, for example, suppose you want to watch a movie and you have to find whether that particular movie has a positive response from the users, negative response, or what. How do you know that one? So a system, because see, a particular movie on the IMDb website gets thousands of reviews. You are not going to read all the reviews one by one. So what you see, the rating, and that rating, how it is being calculated, how the people have written about that particular movie. That is one of the way to finding the cumulative rating. Right. So how the people and how many times people have used the negative opinions, how many times the people have given the positive opinions. So system calculates all those things and give the final score between 0 to 10, that yes, how much good or bad that particular movie is. And based on that rating, now you can decide your decision that whether you have to watch that movie or not. So sentiment analysis, again, it plays very important role, not only in that case, in many cases, like in the political campaign and any other scenario also, sentiment analysis has a very important role. And again, the machine learning system plays a very important role while finding the sentiments of a post, right? Question answering system, right? So suppose we don't know about a particular things. we don't know about machine learning. So what we do, we simply go to the Google, type what is machine learning, and what happens? Number of links appears on our window, right? Most of them, if you will ask the question sort of things, you will get the link of the some of the question answering website like Quora. You will get the link of the Stack Exchange. You will get the link of Yahoo Answer, isn't it? Some question answering website at the top. Then you will get some links of the blogs also, some PDFs, some PPTs. I mean, you will get various links, right? But in the top, you will get the links of some question answering website. Suppose you have opened the link of the Quora to see an answer of a particular question, your question, right? And then you will see that for that particular question, there are many answers which is given, right? How do you find that which answer is more accurate, which answer is correct? Because again, see, there is no checkpoint that no one is checking that while giving the answer, there is no checkpoint that someone can tell you, no, this answer is wrong, you cannot post this answer. So we can post anything, okay? We can post anything and a user is going to come, they are going to read that. So suppose the answer is wrong, you will have the wrong experience about that website. Yes, I read from the Quora, but they are giving the wrong answer about the many things. So I'll not read the Quora. So what the Quora or other question answering websites are doing, they are using the machine learning system. So based on the question context, they are matching that if there are 50 answers which has come for that particular question, which are the questions are closely related to the context of the questions, and then ranking the question based on that one, and keeping only that question at the top which are having the high correlation with the question. Only those answers at the top which are having the high correlation with the question. So again, the machine learning system has the role, and they are finding how much correlation a particular answer has with the question, because it is very difficult again for the excuse me, for the human being to find the correlation, because you have millions of questions, millions of answers throughout the different websites of the question answering, right? Again, machine learning has the application there. Product recommendation, you have visited an e-commerce website, you have suppose bought a laptop. Now they will start recommending you that now buy the laptop case, or you can buy the headphone, or you can buy some speaker, and like that. Now how that recommendation comes? Recommendation happening just because there are a machine learning system behind which is working, and it is giving you the recommendation because based on how the community has purchased the product, or sometimes it will give you the recommendation, personalized recommendation also, and that how you have bought the product last year. Suppose you have bought a cloth. After the cloth you have bought, suppose, mobile. After the mobile you have bought some other thing. So the next year also, maybe after 6 months, again it will recommend you that 6 months before you bought a cloth, so now you may again want to buy a cloth. So like that. So the recommendations, so the system keeps tracks of your history, what you have done and all, and based on that it is giving you the recommendation. And on the recommendation scenario, again, machine learning has the application. Spam detection, we have talked about that one. Last one, what I've mentioned here is protein sequence function prediction. Now this is a part of the bioinformatics. And protein sequence means, suppose you have the protein data or the genomic data like ATGC and protein data. If you are aware about that one, suppose we have the DNA data, and we have to find through that DNA data that what are the disease, or maybe some, if you have a disease, some particular disease, then what are the drugs you should be referred, and many other things, right? Or for a particular disease, how we can design or how we can develop a new drug. For example, for the COVID-19, right? That how we can, the vaccines are now out, but people are working like all over the world to get vaccines, right? So how it's the machine learning system has a very important role in that one. That by seeing a particular sequence, biological sequence data, it can tell that what are the functionality it can perform, in which and all drug it is helpful, and all other things. Right? So it can reduce the time and effort of the biologist. And that is why it is possible that within a year, we are in a position to to have a vaccine, and actually it is out also. maybe someone is like commenting that it is not 100% curable or something. That is different story, but at least we are in a position. Just imagine if this might have happened 20 years back, when we did not have any ML or AI sort of things. Everything biologist had to do in a biological lab, which were taking a year for one experiment also, and coming to one conclusion also, it was taking an year. And nowadays, the same thing we can do within a month, within a week. So ultimately, biologists only doing some everything, but machine learning is reducing their effort and their time. So machine learning has the application in the bioinformatics also. So these are the some diverse, applications area. There are many area. In fact, I would say that wherever you find the data, you can apply the machine learning, or you can apply the data science into that one, data analytics into that one, using the machine learning tools, right? So only thing is you should have the data. Fine. Okay, now moving forward again. So we 12:07. Okay, so we have half an hour left for this session. So next thing, what we are going to learn in now is the different variants of the machine learning system. So we have three different variants which we are going to learn. Means broadly, if we'll classify, we have three different variants: supervised learning, unsupervised learning, and reinforcement learning. Okay, and now we are going to each of the learning variants one by one. Okay, and I'm going to explain with the help of the examples that when we will say that this is a supervised learning problem or this is an unsupervised learning problem. Fine. So let's understand with the help of example. So in the first, in this figure, you can see that there is a system in between, and here we have the input and here we have the output. So as you remember in the previous slide, I explained you that in the machine learning scenario, you should have the input output. Okay, and then you start learning. Then you start the system, then you start the machine learning process, right? So there are two phases in the machine learning system: training and testing. So in the supervised case, when you start the training the system, you should have the input and output with you. Okay, input or output with you. For example, spam detection system you want to develop. So you should have the email and its label, that whether a particular email is a spam or not. So that data set you should have. Okay, if you do not have the data set, you cannot develop the system. You cannot develop the machine learning system, right? So suppose for the time being that you have the data, and the data has the input as the email and output as a label, whether that email is a spam or not a spam, right? So what you will do, you will make the system to learn, and you will make the system to learn. What does it mean? That you will tell the system for this particular email, the label is spam, or for a second email, the label is non-spam. Similarly, for the third email, label is spam. Fourth email, label is spam. And like that, for 100 email, 1000th email, you will pass, and every time you will supervise, or you will tell the system that its label is spam or not a spam, so that system will adapt that one. System will learn that one. Suppose you are repeating the same thing again and again, obviously I will learn, you will learn. Similarly happening that if a similar input we are giving every time, along with its label, system will learn, okay, what are the sentence, what are the words, if it is coming in the email, it is being labeled with a spam, and what are the words, if it is coming in an email, it is labeled with not a spam. So that thing system will learn based on some features, right? The features, sort of feature things I'll talk later, right? So my point is here, whenever in your data set, you have the input and output both, and then you are making the system to learn, and that learning is known as supervised learning. Again, that whenever you have input and output in your data set, and with that input output pair you are making your system to learn, then that learning is called supervised learning. Why? Because for every input you are giving some supervision, that you have to achieve this output. So that supervision you are giving, right? So this learning is known as supervised learning. But if you are learning, you are making the system to learn only on the input data, and you do not have the output, there are some scenario when it happens. For example, clustering. Suppose we are in this FDP, and if I would ask to make the 10 clusters, because I have 10 different question set for the assessment, right? I don't want to give a similar question set for all the participant. So what I will do, I will make 10 different cluster. How I will make the 10 different cluster? That is the question. See, I will 10 different cluster means the input will be, all the participant will be fed as a input. Means suppose I have the 200 participant, all of their name I'll give to the system, or maybe their ID, or maybe their phone number, whatever is the primary key. I'll give it to the system and I'll ask the system, make 10 clusters, right? And system will give us 10 clusters. I am not giving any supervision that on what basis you have to make the 10 cluster. For example, on their maybe on their designation, that suppose there are some like doctorate, make all of them in a one group. If there are some research scholar, keep them in a one cluster. If there are some industry people, keep them in one group. No, I am not giving any supervision. What does it mean? I am not giving any output. Right, I'm only giving the names of the participants, list of the participant to the system, and telling make 10 different cluster, and then system is doing that one. So in this case, you can see that in your data set you have only input, you do not have the output. But earlier when you were doing the supervised learning, you had input and output both. So what is difference between supervised and unsupervised is, whenever in your data you have input output both, and then you are making the system to learn, then that learning is called as supervised learning. But if you are making the system to learn only on the input data, you do not have the output data for every input, then that particular learning is known as unsupervised learning, right? So that particular learning is known as unsupervised learning. So this is a very little difference between supervised and unsupervised. So here we have the output, here we don't have. Coming to the reinforcement learning, in the reinforcement learning, you do not have anything. I mean, you do not have input, you do not have output, but still you want to develop some system. Now, how is that possible? Let's see that. So suppose I'm the agent. Okay, I'm the agent, right? I have suppose visited a place, say Hubli Dharwar in Karnataka, right? And first time I'm visiting this place. So when I'm visiting a particular place for the first time, I do not know anything about that one. Right. For example, I don't know which hotel to stay. I don't know which restaurant to eat. Suppose I have to go to a particular place. I don't know which way to follow. I don't know anything. So as an agent, what I will do? I'll perform one action. The action is I will choose a random hotel. I'll stay there. So that hotel is my environment. And then I will observe what is my experience that in the hotel where I'll stay or in the restaurant where I'll eat, how is the service? For example, in a restaurant, how is the food? Suppose I like the food. I will store that observation in my mind. And suppose in the second day, again, if I come, I'll perform the same action. I'll go to the same restaurant. I'll eat there only. Now that is the human tendency, right? So we don't want to take the chances. Most of the time, if we are in the new place, if somewhere we are getting some good thing, we stick there. Right. But suppose for the first time, if I have gone to a particular restaurant and my experience is very wide, very bad, that observation also we keep in mind and we will not go next time to that restaurant. So initially, agent had no information, means it does not have any input, it does not have any output, but it performs one action based on the environment, whatever it gets, whether it is a success or a failure, that observation it stored in the agent's mind, and if it is successful, that system will be rewarded or that system will be penalized. Same thing happen in the case of reinforcement learning. So reinforcement learning, again, it is a system which start learning with zero. I mean, it does not have any data. We are not providing any data. We take a step. If suppose that a step is wrong, we come back again, take that step. So in the reinforcement learning, we mostly use the dynamic programming. So we are using everything at the dynamic point. So all the dynamic algorithms, whether it is a greedy, suppose we have to move from one place to another place, how to reach that place such that we can minimize our time, minimize like our distance. We can use some of the dynamic algorithms, some optimization algorithm, and everything is being applied in the reinforcement learning. Right. So these are three different broadly classified variants of the machine learning systems. In this workshop, we will stick on these two, supervised learning and the unsupervised learning. Okay. Now, as we have made the difference between the supervised, unsupervised, and reinforcement, in the supervised, again we have regression and classification. So whenever I say that we have to do the regression, that means that you have input and output both. Always remember, if you are going to do the regression, that means that you have input and output both. And in the classification also, you have input and output both in your data. Now, before that, I'll come one step back. So if you want to do any machine learning stuff, you should have the data. If you do not have the data, you cannot do machine learning stuff, anything. I'm not talking about the reinforcement right now. I'm only talking about the supervised and unsupervised. So you must have the data. And that data now, it can have input output both, or it can have only input. So whenever you have the input output both, you will go for the supervised. If you have only input, you will go for the unsupervised. In supervised, again, you may have to do the regression, or you may have to do the classification. Similarly, in the unsupervised, you will do the clustering with the only input data, or sometimes we also do some other things like dimensionality reduction and all, right? So in this FDP, what we are going to see, we will see each and every component, like in one session, means in the next session, in the afternoon today, we'll see the regression analysis, right? Then tomorrow, we'll see first clustering, then we'll see the classification. And then on third day, we will start with the deep learning. But in the deep learning, again, it can have the supervised deep learning system or unsupervised deep learning system. So again, we'll have regression, classification, and dimensionality reduction sort of things in the deep learning also. The concept will be same, only the way we design system in machine learning and the way we design system in the deep learning, that is different, and that we'll learn. Okay, fine. So finally, before I will conclude. So this question we now must ask: when to use which algorithm? Because we have many algorithms, right? Now I had given you the clue that when to use which algorithm, that is completely depend on the problem. Okay, it is completely depend on the problem and data. So you must have the data with you. By seeing the data, its properties, that whether it has output or not, okay, you can decide that, okay, I should go for the supervised, or I should go for the unsupervised. Or sometimes in the data set, you will have input, output, or you will have many things, but the problem is something different. So it is also important to understand what is the problem and what is the data set which has been given. Now, based on that, you can decide which algorithm to use when, right? Okay, I'll give you the one example, which algorithm to use when. For example, suppose I have one review. This is a review which I have taken from the Amazon. Now, this has many information, right? For example, it has the like star rating, it has the heading of the review, it has the date in which it has been posted, body of this review, image, 52 people found this helpful, the helpful button, and many other things. Suppose I have extracted some of the things from this one. I have extracted a rating, which is 1 here, review text, which is written here, vote, which is 52 in this case, and product quality is low. Why? Because the rating, suppose someone has given the product as star 1, that means the product quality is low. And based on that one, this column I have added as low. Similarly, suppose for second review or third review also, I have gathered these 4 information. Okay, their rating, their review text, their vote, and their product quality. So now I have prepared my data set in this way, that I have rating, I have review text, I have vote, I have product quality. Fine. Now see the question. Based on the review text, you have to decide, or you have to find how many votes that review will receive. Now suppose that is the question. Okay, that is the problem statement what you have given, and this is the data set what you have been given. Now, which algorithm you will use, which machine learning algorithm you will use, right? So now see, you will observe that in your data set, what are the fields you have? Do you have the input? You will find that yes, I have the input as a review text. Okay, do you have the output? You will your answer will be yes, you have the vote, because the problem statement is the system has to identify that if the review text is given, how many vote it will receive, and both information you have in your data set. So if you have the input and if you have the output, which algorithm you will use? You will go for the supervised case, supervised machine learning algorithm. Now this is how you will figure it out, that whether I should go for the supervised or unsupervised based on the problem and based on the data. Now suppose you know that I have to go for the supervised. In supervised, which algorithm? Because you have regression and regression and classification, two options. So now see, there is a very simple difference. I'll tell you that how to identify whether I have to go for the regression or for the classification. So in the output, I mean, review text was my input and vote was my output, right? So in the output, you just see vote is my output. So in the output, you see if you have the fixed number of output or you have the infinite number of output. For example, a review will receive how many votes? Do we have any upper limit for that one? No, we don't have any upper. A review can receive 1 vote. It can receive 0 vote at minimum. And it can go up to 10, 100, 1000, lakh. It can go up to infinite. So in the output, you don't know how many votes a particular review will receive. For example, the first review here, it has received 52 votes. Second review, it has received 6 votes. Third review, it has received 42 votes. Can you tell me how many votes this particular last review will receive? Your answer, I mean, you cannot fix that, yes, it will receive the review only between 0 to 1000 or only between 0 to lakh. We don't know. At least by seeing, we cannot say. Based on some features, we can say, right? And that's what the machine does. So whenever in the output, the limit is not fixed, then that particular problem is a regression problem. So there is no range for the output. It can be anything between 0 to infinity. It can be anything. Then whenever the output range is in infinite, you will then that particular problem is a regression based problem. For example, suppose you have to predict the price of a particular house. Now the price of a particular house could be anything. It can be like rent. Suppose I'm talking about the rent. It can be 8,100. It could be 8,200 for 2 BHK. It could be 8,300, 8,350 rupees. I mean, it can be anything in the fractions also. We cannot accurately predict them. We cannot accurately find that how many. We cannot exactly say that it can be only 8,000 or only 9,000 or only 10,000. No, we cannot say that one. It can be 8,500 also, it could be 8,200 also, and like that. So my point is, whenever in your output, you will find that there is no upper limit or you do not have any fixed number of output, then that problem is known as regression problem. Okay. And now suppose I will change my problem statement. Now with the same data set, now I will say that if you have been given this data, you have to design a system such that the system can tell whether a particular review, based on the review, whether a particular product has the quality low or quality high. Now my problem statement is completely changed, but the data set is same. Again, you will try to observe, do I have the input? You will get the answer, yes, I have the input as the review text. Do I have the output? Answer is again yes, because you have the output as product quality. So if you have input or output, you will go for the supervised learning. That is fine. But in the supervised, whether I have to go for the regression or classification, how do we figure it out? Now see again, you will see the output. Now this time the output is this product quality. Earlier we had the output as word count, but now the product quality. In the product quality, now see, do we have the fixed number of output? The answer is yes. Why? Because see, for this first review, the output is low. For second review, output is low. For third review, output is high. And then if you have thousands of reviews also, or you have millions of reviews also, every review will be labeled with either low or high. You will not have the third output. You will have either 0 or 1. That's all. And because the number of output is fixed, we will go for the classification. Right? This is how you have to discriminate. You have to differentiate between the regression and the classification based on the problem statement given and based on the data set given. So now, if I'll say that if I have, review word count, and I have to predict the vote. Okay, if I have the review and its word count as an input, and I have to predict the vote, it is a regression based problem. Why? Because here the output, which is vote, is infinite. We cannot find what vote could be. It can be anything between 0 to infinity. But here the output are fixed. That we have a particular review which has a word count 27, it fall into the class 0. And the word count of review, if it is 2, it fall into the class 0. If the word count is 100, that means that review has been explained very well and it is falling into the class 1. But we have here only two classes, either 0 or 1. So it is a classification based problem, right? We will go into the more detail about all these concepts, that what is classification and what is regression, in a dedicated session, which is already given in the schedule. So I'm going to stop here now. Because it's time, and I will be open for the question from next 5 minutes. And before that one, I will tell you that in the next session, in the afternoon, after the lunch, which will start at 2:30, and 2:30 to 3:45, we will learn more about the regression, that how exactly what we do in the regression, what is the idea behind regression. And then when we learn tomorrow about the classification, then you will be able to differentiate, okay, in the regression, we have to fit a line such that all the points should be very near to that point. But in the classification, we have to draw a line such that two classes of data should be very far from each other. Okay, so those things you will learn in the dedicated session, which we have kept for the classification and the regression. So in the afternoon session, all of you are requested to attend the session, in fact, all the session in all 5 days, so that you can understand the logic better by particular speakers, which will be delivered by speakers, right? Now, I'm going to stop here right now. So I'm open for the question. If you have any question, please ask me. Okay, house price prediction not clear. Slide not changing. Was it happening at 11:37? I mean, I think not. It was, yeah. So, okay. Muhammad Ahmad sir has asked one question, that the house price prediction not clear. Okay, I'll tell you, sir, that suppose I have to, a system we have designed, a system has to predict the price of a particular house. And suppose we are feeding some of the features. For example, it is a 1 BHK or 2 BHK or 3 BHK. That is one feature, right? Second feature is that house, what is its area? It is 800 square feet, 900 square feet, 1200 square feet, or what it is. That is the second feature. Now, third feature, suppose it is in a rural area or in an urban area, like that. So suppose 3-4 features we have. And based on that one, the system has to predict what is its price. Right. Now, we know that the price could be anything. No, we can figure it out. Its price could be around 8,000. Why? Because it's the 2 BHK. It is in the urban area, or maybe 800 square feet. So we can say that when it could be around 8,000. But when you will do the same thing with the help of system, the system will tell you 8,000.500 or something. I mean, it will not give you the exact value of that house. You can then round it off. Okay, you can then round it off to the nearest integer, but it will never give you the exact value. Okay, it will never give you the exact value. So for every different features, I mean, for one feature, say 1 BHK, 800 square feet, and urban area, you will get the price 8,000. The next time, for the other data, you will get the price 8,500. For the next data, you will get the price 8,900. I mean, you can get any value between 8,000, say 9,000. Although we know that it's the house price must not exceed 9,000, but we cannot be very sure if the system will predict that whether it is only 8,000 or only 8,005 rupees or only 8,010 rupees, means your output will be anything between 8,000 to 9,000. And if you will count how many data points we can have between two integers, you can have infinite numbers. If you will take all the consideration of the decimals and all the values which can come after and before the decimals. So that's what I was talking in terms of the regression, that predicting the price of a house, it is a regression based problem where output could be anything. It can come in an infinite range. That's in that same sense I was talking. Please tell about ML application in sentiment analysis, right? Sentiment analysis, I have told you, one of the application I'll tell you again, that in Twitter, suppose there is a campaign going on about a product. Suppose I have, or about politics, right? And we want to know that the people is going to vote to whom? To a particular party, I mean the A or B, right? And then what happens? Suppose you will someone will tweet, right, a particular suppose a party X, they will tweet, their chairman will tweet with a particular hashtag, and they will ask that to whoever in the support of that one, please retweet this one or something, and blah blah, right? And then with the sentiment analysis, you will try to find it out that how many percent, I mean the percentage of the people are in a particular region, whether they are in favor of you or in the against of you. I mean, they are giving the positive response to you or the negative response to you. So getting the positive or negative opinion, it is nothing but the sentiment analysis, and that you can do through the social media, in the social media for your marketing aspect. Like if you have launched any product and you want to know what is the view of the people or the customers about the product quality, you can get that information through the sentiment analysis. For the political aspects, I have already told you. For the movies, whether I should watch or not. So for everything, you can get it if you have the machine learning at the back end through the social media post. So there we have the application of this sentiment analysis. I'm going to use for hands-on session. Yeah, I have told you, I think I mentioned it. So you don't have to install anything on your local system. So everything we will install. I mean, we are not going to install anything. Everything we will be doing on the cloud. So we will use Google Colab. Google Colab. I will show you step by step that if you have the Gmail account, you have the connected Drive account, then how you can open the Google Colab if you are not aware, right? If you are aware, that is really appreciated. If you're not aware, I will take you step by step, everything. I'll explain that how to go to the Google Colab, from where we can start, how to connect the Colab with the Drive, and then how to start building the model and doing training, testing, and prediction, and building the models. So tomorrow, when we'll start with that one, I'm going to tell you. So you don't have to install anything in your local system.
Hello, sir.
Yeah, ma'am. Tell me.
Hello.
Yeah.
Is this session will also cover how machine learning algorithms we can apply on the images for detection anything?
Yeah, definitely. Because anyway, I am going to cover all the hands-on except one. So I will definitely tell you that how to do the image processing. I will tell you definitely. Yeah. Thank you.
Yeah, thank you
for your interest.
So are we going to use Python for this?
Yeah, we will use the Python as a programming language, but different libraries. Yes.
Okay.
Hopefully the concept what I have given, it's clear. If you are confused with some of the concept, please ask me.
Excuse me, sir.
Yeah.
Yeah, would we be using the scikit-learn library of Python for this?
Yes, for machine learning models, when we will build, we'll use the sklearn, scikit-learn library. And when we'll go for the deep learning models, we'll use the keras.
All right. All right. Thank you, sir.
Okay. Scope of transparency of ML systems to the user. Transparency, everything is transparent. Why? Because everything is mathematical. I mean, we are not doing anything anything on the sky, right? So all the ML model, all the deep learning model, they are working because there is a mathematics behind. Okay. It's not like us as a human being, we will predict, no, the train will be half an hour late based on our intuition. No. Mathematics is behind, and whatever output you are getting, that is the output. Everything is transparent. You can get the information that at which layer, what is happening, which parameter, what is its value. So everything is transparent in the case of machine learning, because everything is mathematical. All models are mathematical. So mathematics is working behind. Fine. Any other questions if we have from the participants? So I would like to assure you the sessions is going to be very interesting, and we'll start with from very basic things, right? And particularly whatever I will take in the hands-on sessions, please attend, and in fact you attend all the sessions, then only you will understand the hands-on. And hands-on session you must attend, because there you will get the practical approach how to start with the machine learning if you have not done so far. And I'm going to take the session, so I assure you that I'm going to clear all your doubts, mostly all of your doubts. Yes. Right. So if we do not have any further question for now, we will close this session and we'll sharply connect at 2:20 so that we can start the session at 2:30. Right. There we will discuss about the regression analysis, which will be engaged by Dr. Ramesh Ate, Indian Institute of Information Technology, Dharwad. Any further clarification if you want, then you can ask me. Well, if we do not have any questions for now, so you can go through the things what we have discussed. If you have the questions later on also, we are anyway together for next 5 days, so we can discuss anytime, and I'm available all the time, so we can discuss all the things, whatever will come across in all 5 days. So if it is not happening during the session, we can do that one after the session. You can clarify the dots. If I can solve your dots, we can definitely have all the discussion session anytime, right? So thank you so much, all of you. We'll connect at 2:20. So please connect, have your lunch, and then we'll connect and we'll continue with our session. Thank you so much. Till then, I'll see you again.
Thank you very much, sir.
Yeah. Okay. Okay, sir.